The limb is fitted. The AI designed it overnight. Orthotists and prosthetists are the specialists who restore movement, independence, and dignity to patients who have lost a limb or whose bodies need orthotic support to function. They combine biomechanical expertise, clinical assessment, and precision engineering to create devices tailored to each individual. But artificial intelligence is now scanning bodies in seconds, generating custom socket designs, and predicting gait patterns before a single component is fabricated. So, is the orthotist and prosthetist facing an AI revolution? And what does this mean for the clinician at the fitting bench today? Let us start with what AI is already doing in the world of orthotics and prosthetics. AI-powered 3D scanning and design tools are now capturing residual limb geometry in under 30 seconds, generating prosthetic socket designs automatically that would previously require hours of manual casting, measuring, and computer-aided design. Companies like SYFX and Unlimited Tomorrow are using this technology to deliver custom prosthetics faster and at a fraction of the traditional cost. Machine learning algorithms are analyzing gait data from wearable sensors and force plates to predict the optimal prosthetic alignment and component selection for individual patients, reducing the number of fitting appointments required and improving functional outcomes from the first fitting. AI-integrated microprocessor prosthetic knees and ankle-foot systems such as the Osha Rio Knee and the Ottobock Meridium are learning from each patient's movement patterns, continuously adapting in real time to terrain, speed, and load. These intelligent devices are changing the nature of prosthetic prescription. Computer vision and AI gait analysis platforms are assessing patients during walking trials, identifying deviations in symmetry, cadence, and posture, and generating fitting recommendations, work that currently relies on the trained eye of an experienced practitioner. AI-assisted orthotic design software is generating custom ankle-foot orthoses, spinal bracing, and upper limb supports directly from scan data, reducing the fabrication cycle from weeks to days and enabling remote delivery of devices to patients in areas without specialist access. But here is where the orthotist and prosthetist remains absolutely irreplaceable. The clinical relationship at the center of orthotics and prosthetics is irreducibly human. Amputees and patients with complex disabilities are navigating profound physical and psychological challenges. The skill of building trust, understanding a patient's lifestyle, goals, and emotional state, and translating that into a device that genuinely fits their life is not something any algorithm can replicate. Complex residual limb pathologies, skin breakdown, volume fluctuation, vascular compromise, neurological conditions, and pediatric growth require clinical reasoning that goes far beyond geometry. The orthotist and prosthetist reading the tissue, asking the right questions, and making micro-adjustments based on pain, sensation, and function is an irreplaceable clinical skill. Advanced prosthetic upper limb rehabilitation, including myoelectric and bionic hand fitting, osseointegration, and targeted muscle reinnervation, is a highly specialized clinical discipline where human expertise, patient coaching, and iterative fitting are central to success. Orthotists who develop expertise in pediatric orthotics, sports prosthetics, neurorehabilitation, spinal orthotics, and complex lower limb biomechanics will be among the most valued practitioners in the field. And practitioners who become proficient in AI-assisted scanning, digital design workflows, and intelligent prosthetic programming will dramatically expand their clinical capacity and the quality of care they deliver. So, will orthotists and prosthetists be obsolete by 2030? The reality is this: routine, straightforward orthotic provision, off-the-shelf insoles, simple ankle supports, stock bracing will increasingly be automated and delivered through digital platforms, reducing demand for lower complexity clinical input. However, the demand for specialist orthotist and prosthetist expertise is growing, driven by aging populations, rising rates of diabetes and peripheral vascular disease, the global expansion of prosthetic access programs, advances in bionic technology, and the increasing complexity of rehabilitation pathways. The British Association of Prosthetists and Orthotists has highlighted that the workforce faces a critical shortage, not a surplus, and that AI will augment clinical capability rather than displace experienced practitioners in complex care settings. Orthotists and prosthetists who develop expertise in bionic upper limb systems, osseointegration rehabilitation, pediatric orthotics, sports performance prosthetics, and AI-assisted digital fabrication workflows will be among the most sought-after clinical professionals in rehabilitation medicine by 2030. Those most at risk are practitioners who remain focused solely on routine provision without developing specialist clinical depth or digital fabrication skills. By 2030, the fitting room will look very different. AI will generate the design. The scan will take 30 seconds. But the orthotist will still be the one who looks the patient in the eye, understands their life, and ensures the device truly fits not just the limb, but the person. AI is not replacing the orthotist or prosthetist. It is placing the most precise fabrication tool ever built in their hands. The future of prosthetics is not the algorithm or the scanner. It is the clinician who knows how to use both.